Hello, everyone. Good morning, good afternoon, good evening. I'm Jayashree Hegde, welcoming you all to this exciting webinar on Accelerate Industry 4.0 with Event Native API Management and MQTT. Allow me to introduce you all to our speakers for today. Ravi Subramanyan, Director of Industry Solutions Manufacturing at HiveMQ, and Alex Drag, Director of Product Marketing at Gravity.io. Welcome, Ravi and Alex. A pleasure to have you both. Before we kick off the session, I would like to share that we are recording this webinar and we will share the presentation slides as well as the recording of the webinar in a follow-up email. I do see that a couple of questions in the chat asking how long is this webinar? It's a 60 minutes webinar. And during the presentation, if you have any questions, feel free to add them to the Q&A box, which you will find in the control panel below. We will have a dedicated Q&A after the presentation and the demo. We will be running a quick poll during the Q&A. I request you all to cast your votes. Now, without further ado, I will hand it over to Ravi and let both the speakers introduce themselves. Welcome, everyone.
Thank you, Jayashree, and good morning, good afternoon to everyone, to all our friends across the world. My name is Ravi Subramanyan. I'm Director of Industry Solutions for Manufacturing for HiveMQ. And I'm very glad to also introduce Alex. Would you like to introduce yourself, Alex?
Yeah, absolutely. Thanks, Ravi. I really appreciate you with the introduction there, and I appreciate the entire HiveMQ team, of course, for inviting Gravity to join this webinar, and I appreciate everyone who's joining to join and sort of listen to what we got to talk about today. So it's really exciting. Like Ravi said, my name is Alex Drag. I'm the Director of Product Marketing and Product Specialist here at Gravity. So I'm a big fan, super interested in all things APIs and API management. And over the past few months, I've become a huge fan of event streaming, MQTT, IoT, et cetera, et cetera. And I'm excited to be talking about that later today on this webinar.
Absolutely, absolutely. And as people know, HiveMQ is one of the premium MQTT-based brokers, which is very attuned to IIoT use cases, and with the working with Gravity, I think we can extend the use cases to a lot of the IT-based protocols, mixing that or combining that with the power of MQTT. So we are very excited about our partnership here. With that said, let me just jump into the presentation here. So first, what are some of the challenges that we see in manufacturing, right? I mean, these are kind of like ubiquitous across the different manufacturing industry verticals. Material shortages, that is rampant because of COVID. You have global supply chain issues because supply chains that were deemed to be very ironclad are not as ironclad, and they are pretty fragile, right? Carbon footprint, energy costs continue to be like to cause a big impact on the profit margins. Security vulnerabilities, anytime you take the data out of your premise, there is always going to be concerns and that need to be overcome. Demographic changes, this is across the board, not just for manufacturing. So obviously there's skill shortages because of a lot of retirements that's happening. So the tribal knowledge of people that have this knowledge are retiring, and the younger talent that is coming in may not have as much interest in the kinds of jobs that are typical in manufacturing or the knowledge, right? So there is that issue. And then last but not least, regulations and bureaucracy continue to happen and then cause big burdens. So when you look at smart manufacturing, right? So that basically the promise of smart manufacturing is that you can use the technology, right, to be able to do better management of your processes from an industrial perspective, right? You can ensure that you have optimization on your manufacturing processes that you have. You can predict machine failures before it happens so that you don't have any unplanned downtimes. You can improve your supply chain, meaning you can connect different systems together and have a more bigger visibility into supply chain. You can connect disparate data sources together and create a data plane that you couldn't do otherwise, if you will, right? You have certain data in, say, your ERP system, certain data in other systems, if you will. And the promise is that you want to be able to connect your OT systems that are traditionally kind of sitting on their own island into the IT systems. That's kind of the promise of smart manufacturing, right? And to be able to achieve that, you have Industry 4.0 as an umbrella term that's used for all of the technologies that can be used to enable smart manufacturing, including all of the things that we are showing here. So when you look at like various reports are out, like a major report that came out from McKinsey is that by adopting the Industry 4.0 across the industries, you can actually get all of these benefits, right? And this is kind of like the tip of the iceberg. There's a lot more that you can do beyond that, but like these are some things that customers can expect to get. And obviously, from a short and long-term impact perspective, there is the automation, right? So we talked about some of the challenges. So automation helps you kind of not like eliminate workforce, but like more to all the repeated process. We talk about chat GPT, right? And whether chat GPT can actually replace humans. Contrary to that, it can actually automate some of the things that happen in a mundane fashion, in like a repeatable fashion. So human beings can focus on some of the more important things, can take the organization to the next level, if you will, right? Operational efficiency, that's absolutely important, right? You want to be able to increase your productivity and increase margins. Supply chain, we talked about it, how you can bring the supply chain to reduce the risks, if you will, on your products, and your ability to deliver based on like the demand that's coming in, if you will, right? Security, again, the ability to connect plants to data centers to cloud or whatever the other components to eliminate your business interruption. And last but not least, you can use this to create new innovative products, because obviously that's something that has become very, very important. How can you create innovative products, but products that are more impactful on the environment as well? So try to eliminate waste, create innovative products. So it's a win-win situation. So when you look at like the data maturity model, as we like to call it, and this is a triangle, right? So the triangle, the promise of Industry 4.0 is right on top, where you have the actionable, synthesized, and organized data, where you have all of the things that in your fingertips to be able to do all of the things that you want: AI, ML, data analytics, and things like that. But right at the bottom, right, that's kind of like the most important aspect of this triangle, which is data. And the most important verb or the task is data collection, right? Because without being able to collect data and be able to present the data to the above layers, none of the things that you put in place is really going to be impactful, right? We talk about digital twins, we talk about all of the other cool things, but your twin is only as good as the data that is fed into it, right? So again, from a data collection perspective, that's absolutely key. And that has to kind of be enabled, and it has to be robust, and it has to be bidirectional, and it has to be contextual, meaning like the data has to be always available as opposed to making it available once and being done, right? So that's kind of like the whole data maturity model, where the collection and availability becomes absolutely key to enabling the rest of the stages of data maturity. And we have this other concept of the data collection loop. So we're basically taking the data collection, and we are talking about this infinite loop, where it's not just about like just gathering once and providing that, right? It's you're gathering data, where you're gathering data from your smart sensors, other data sources, and then you have to send it for the data to be analyzed, either on premise or on the edge or the cloud, right? And then that has to be shared with some enterprise system, right? Again, you are on premise or on cloud. And then that can be used to control the endpoints back in the field, right? Like, for example, you can have like a remote SCADA system, for example, manage your endpoints, or you can have like a remote system be able to monitor aspects of your operations and make some changes as needed, tweak some changes. So this loop keeps continuing. And so this value creation loop is absolutely enabled by the data collection and the data availability. Let's look at some reference architectures with what we call the unified namespace, and I'll introduce a concept of unified namespace as we talk about that. So traditional connections, if you will, between the OT systems and IT systems are client-server based, and typically they are direct connection. It's not scalable because obviously, when you consider the millions of devices or applications or systems that need to be connected, very soon it's going to be unmanageable, right? Where you have direct connections, it's a hit on your bandwidth, it's a hit on like efficiencies, your connectivity, and a variety of other things. As opposed to that, what is the new way of doing it is using a unified namespace, which is kind of like a centralized entity, if you will, which every every system that needs to communicate with every other system is basically going through this unified namespace. And they have like different unified namespace as different topic name structures where the publishers, for example, on the OT systems can publish data to that namespace. And then anybody that needs to receive that information can receive that on the IT side. And it's also vice versa. So you have what we call a single source of truth at the end, at the center, that can basically manage all of the communications efficiently. And so you only need to turn on the communication when you need it, and you can turn it off when you don't need it. Right. And so it's obviously better in like low connectivity situations. It's better from a bandwidth efficiency perspective. It's better from a overall efficiency perspective as well. And it's easily scalable. So you can add more of these publishers and subscribers as you need it. So it's very efficient from that perspective as well. And so let's talk about MQTT, right? So MQTT is a protocol that started in the late 90s. It was created specifically for the oil and gas, remote oil and gas use cases for Phillips 66 by two gentlemen from IBM. And the use case or the problem statement was that, hey, we have remote oil wells that don't have good connectivity, don't have good bandwidth. How do we ensure that like whatever mechanism we have to be able to connect those remote oil wells to the enterprise or to the premise is efficient and able to manage with all the what we call the harsh conditions that is available from a connectivity and network bandwidth perspective, right? That's how MQTT was born. It is a publish subscribe based protocol, meaning like there are a bunch of publishers, a bunch of subscribers, and when the publishers need to publish data, they publish it to like a centralized broker, right? That is sitting at the center, and this broker is then brokering connections or the communication to anybody that needs to receive it. For example, I'm a publisher, I'm publishing, say, the temperature, and you have like a mobile device or a backend subscriber that needs to get that information that's subscribed to that topic name structure, they automatically get it. And they don't have to talk to the publisher directly. And so that's a very efficient use of your network connectivity. It works well with the limited bandwidth, limited battery power, and so on. And the good thing about MQTT is built on TCP IP, which is very robust from a connection perspective. And it's very ideal for IIoT because of the ability of it to scale and the ability for it to work in these constrained environments. And so pulling it all together using what we call a Sparkplug-based architecture. Sparkplug is a protocol that is sitting on top of MQTT that provides additional feature functionality for manufacturing, like, for example, the data model, right? So you have, in a factory environment, you have like different subsystems that are not publishing data separately, but as a part of the whole subsystem, and you have typically some data models associated with them. So you have to have like the subscribers be able to identify what that data model. So Sparkplug helps you create that, and a bunch of other cool features as well. So this is kind of like how we see the world of the architecture of an IIoT coming together with a centralized broker, which is basically the unified namespace, and connecting all of the systems on your OT side to the IT side and vice versa. Okay, let's quickly talk about who HiveMQ is, right? HiveMQ started in 2012 in a place called Landshut, right outside of Munich. And since its inception, we have been laser focused on being able to connect the data from like clients to enterprise using our enterprise grade broker, which is based on MQTT, as mentioned. And over the years, we have kind of like bootstrapped our company. And recently, we actually have gone through like a seed round and a Series A, and we've gotten like about 50 million euros through that. And we're pumping that back into our technology and trying to get to the next level, if you will, right? We have 160 plus employees with 180 plus customers that trust us in different industry verticals, including manufacturing, logistics, and transportation, connected cars, where we really got our first footing there, and a bunch of other industry verticals. And here is like an array of some of our customers. We are part of the MQTT, like the Eclipse Foundation that manages MQTT, and also Sparkplug. So we are heavy proponents of open source, because obviously open source is the way to kind of ensure that like you have multiple vendors coming together and providing value to their customers. So we are a heavy believers in this and a proponent of that. And this is kind of like our overall offering, if you will, where we have our broker, we have your devices that are publishing into the broker either directly or through like a gateway device, if you will, right? And the gateway device is needed if the end device doesn't understand the MQTT protocol. So you need some kind of consolidation device. And then what we do is we can extend that data into your IT systems, either if the IT system can talk MQTT, or we have what we call an enterprise extension framework using our software development toolkit, where we can talk to different enterprises like Google PubSub. We built some of these extensions, and it's easily, anybody can take our SDKs and build other extensions, custom extensions, for example. And one of the things that we have done is that we have taken MQTT and we have taken it to the next level by being a very highly scalable, highly available, reliable, secure data bus or data platform using our MQTT protocol. And we are very flexible in terms of where we can publish the data. And we can run anywhere. We can run on premise, we can run on the cloud, or we can run based on the customer needs. And these are some of our array of our extensions that we have to offer. All right, so at this point, I would like to hand it over to Alex to talk about what is API, how does API management fit into this framework that we talked about from a HiveMQ perspective. So over to you, Alex. I'm going to be jumping to the next slide for you to talk about.
Sure, awesome. Thanks, Ravi. So yeah, look, we've been talking about a lot on this webinar so far. I think if we're to sum up essentially what we're trying to accomplish, sort of some of what our motivations are here. At the end of the day, we're talking about how and where information moves. We want to make sure the right information gets to the right place in the right way. We definitely want to make sure that right information doesn't get to the wrong people in the wrong places.
Sure.
Right. And here at Gravity, we like to kind of think about sort of three different paradigms, right? You mentioned, Ravi, this sort of PubSub system. We think a lot about event streaming. So we're going to ignore sort of this sort of synchronous form of communication or purely synchronous form of communication. And we're going to talk about these sort of three paradigms of evented communication or asynchronous communication or streaming communication, whatever kind of word you prefer. So the first sort of paradigm we refer to is eventing backend or eventing internal systems. I know backend isn't perfect, but oftentimes these are the internal systems that we're eventing. So you can see here on the left, you've got producers, consumers, both internal systems behind some layer of protection like a firewall, and they talk natively. Ravi, you mentioned earlier, HiveMQ, MQTT, great, they can talk to natively. There are challenges here for sure, but things really start to get more challenging as you sort of shift right here across these different paradigms. Where paradigm number two is what I call it, bringing the power of events to other backend or internal systems. And by other, I mean other systems that might communicate over different protocols. Think about something like Kafka. Maybe you have some internal consumers that want access to that MQTT data over a REST API, right? I mean, REST still rules the world in many places, right? So there are some applications that instead of sort of ripping out REST and being turned into MQTT clients, they might just want to continue to be REST clients, and they still want that information from an MQTT broker, for example. Still internal systems, still behind a firewall, right? So there might still be some security concerns here, but it'll be a little less challenging given that things are still internal. But as you mentioned earlier, Ravi, there's still this need in order to be able to extend that MQTT data information into something that might not communicate natively over MQTT, right? Something like protocol mediation, that's what we call it here. Some sort of extension, whatever it might be. And then this third paradigm, we'll focus more on this one for the rest of the conversation, what I call unleashing your events in real-time data. So you'll see here in the first two paradigms, you have your producers and consumers, all internal, behind a firewall. Now you're taking that next big leap and you're exposing that MQTT data or that IoT data or those events, those messages, whatever it might be, to external consumers that might exist outside of your internal network or your firewall, right? And
awesome.
Who knows how these consumers choose to consume information or prefer to consume information. For example, we have some customers that are actually running MQTT, HiveMQ, that are interested in exposing this information to external, potentially paying customers who are interested in that data. But those paying customers, there's actually a variety of them. Some of them have applications that want to consume that information over REST. Some of them want to consume that information over WebSocket for bidirectional real-time communication, some webhooks, some SSE, there's a variety, right? And what these folks have at their disposal, if they can actually accomplish that feat, expose it securely, expose it reliably, because right, these are all major concerns. I think anyone in the IoT world is aware that security has historically been something that's concerning. But if they can do this effectively, they can actually sell this data, right? And the more support they have for various different communication paradigms, API styles, protocols, et cetera, the more potential revenue they can generate, right? This really looks like truly productizing your data. So Ravi, if you'll move to the next slide, we'll sort of dive into these last two paradigms, because I think this really is where you see the power of something like HiveMQ and Gravity fully on display, right? So once again, let's just recap these two paradigms. One, you've got still internal, but maybe two internal stakeholders that communicate over some different protocol or API style. So let's take the example of MQTT and Kafka, right? And the third one is, once again, you're exposing the information to external consumers outside of your firewall, could be running on MQTT or could not, right? So let's address some of the challenges here. And Rob, I think you've covered a bunch of the motivations, whether it be increasing operational efficiency. I've mentioned some stuff about productizing your IoT data and actually selling it as a product, still making more systems efficient. But some of the challenges here that exist really for both of these, you still have some security risks and concerns potentially on that second paradigm. We're still exposing to internal consumers. Just because someone's an internal consumer doesn't mean they should have access to specific data or certain data sets, right? Let's say, I don't know, some sensor or something somewhere is capturing data that might be PII, right? You want to make sure that only certain applications and developers internally might have access to that. In the realm of efficiency, you might be concerned about making sure that certain consumers will actually talk about this with a policy. And when I show a demo, you're gonna make sure certain consumers might get data under only under certain conditions. So maybe you need something like a filtering policy or some sort of filtering logic. Right, so there's some security concerns, some efficiency concerns still there on that second paradigm, but especially on the third, right? Where now you have people who are trying to access data that are outside of your firewall. So security becomes totally paramount. And of course, there is still the issue here where you have MQTT, Kafka, WebSocket, REST, Webhook, whatever it might be running around, you have the upscaling challenges. Right, I mentioned earlier that sort of REST still rules the world in many places, just because you might be a developer, might be a team that has a ton of REST skill sets, but maybe you don't have the Kafka skill sets or the MQTT skill sets, right? If you want to be able to consume that information coming from some MQTT broker or client. And that sort of bleeds into that next challenge here, mediating between everything. Look, there are mediation solutions out there. You can create your own, you can buy some, but it is still a challenge that needs to be solved. Right? If you do create your own, this can get really, really tough, especially once you start thinking about building mediation that works alongside of certain security mechanisms, reliability mechanisms, or efficiency mechanisms like filtering or transformation policies, et cetera, et cetera. And then this last one, I like to talk about this a lot. How do people internally or externally even know that this data and access to this data exists, right? You might be some team that you're managing some MQTT broker or some MQTT-based system using HiveMQ, for example, right? You know that you have some seriously important and critical resources that are being brokered by HiveMQ that tons of other teams, either internally or maybe some customers externally, could find valuable. How are you going to make sure they know? You could do this manually, right? And just send emails to everyone and say, hey, here it is. If you want to subscribe, do this, this, and this. Or you could think about maybe a bit more sophisticated solution in exposing that service and access to that data and information in something like a developer portal, right? Which is basically just a catalog of services, APIs, access to data, et cetera, so people could access it in a self-service manner, right? And we'll talk a little bit more about that later as well. So when we look at this list of challenges, there's clearly some benefits here, right? That if we can get past these challenges that the teams can attain and achieve, there is a necessary solution set. Of course, there's the build your own. Anything can be built, right? But we all know that's not always the most efficient manner to go forward in. So the solution set, if we're looking at something like enterprise tooling, you're going to want to look at something like an event broker. Think about something like a HiveMQ, right? Specific to MQTT. I'm sure everyone on the call here loves MQTT. If you're an IoT fanatic, you're going to love that. So I think HiveMQ is an awesome solution. Beyond things like MQTT, Kafka skill set, that's really important. You're also going to look at something like event native API management, right? And this is where Gravity comes in, and this is where I sort of get on my high horse and start talking about what I think the future of API management looks like. So Ravi, if you could skip to the next slide. Yep. So we're going to talk about what this is. So I like to explain event native API management. I like to sort of set some context first and look at sort of the evolution of API management and APIs. So look, we like to say that we all lived in a simpler time. I want to focus on that word simple. It does not mean easy. It was just less complicated, less moving parts, less parts talking over different protocols and API styles, right? When you look at sort of the historical trajectory of API management, we sort of start in this universe where you have a bunch of REST APIs, maybe some SOAP web services, right, that need some sort of protection, right? For those of you who are not familiar with API management and API gateways is sort of a core fundamental component of API management solutions and strategies. At a very high level, what's going on is you have some backend API, right, that's going to broker access to specific information, data, functionality, something that some consumer somewhere wants, right? Now that backend API needs to be protected for multiple reasons, whether it be security reasons or reliability reasons. And there are also some ways to make things a bit more efficient. So for example, you might transform some of the content, right, that might be being sent to a consumer. So the API gateway essentially sits as this proxy layer between consumer and backend, consumer and essentially data source or target, typically some backend system and backend API, right? And that gateway can authenticate, it can authorize, it can apply certain policies, and essentially just logic, right? That can control and protect that API, how it's consumed, who it's consumed by, et cetera, et cetera. So in the early days of API management, you had a bunch of REST APIs running around, right? Every API gateway out there worth its salt supports REST APIs, supports the HTTP protocol. It can sit there, it can proxy request, proxy response, protect that API, get that consumer the data that they're authorized and authenticated to access where they want it, right? So once again, not necessarily easy. The gateway is still accomplishing difficult tasks, but it's less complicated, right? When everything that's running around is just REST-based, right? You have a gateway that can support that, you're, for the most part, good. Ravi, if you'll skip to the next slide. So things then got more challenging, right? And this is where we live today. Event-driven systems, event-driven architecture streaming is not necessarily new, but it is something that is sort of in vogue again. So what we're seeing a lot in the market with our customers and what we're hearing when we talk to partners like HiveMQ is that there's a lot more than REST running around. Clearly on this webinar, we've talked a lot about MQTT and asynchronous forms of communication specific to IoT, for example. So what ended up happening is as organizations started implementing both on the client side and on the backend side, asynchronous forms of communication. You're looking at event brokers, message queues, asynchronous APIs, think REST, think WebSocket, Webhook, SSE, think Kafka, think HiveMQ. The gateway started failing, essentially, right? It could continue to work in some of these situations where only support for REST was necessary. And then sometimes in very limited situations where something like you need to be able to post information from REST-based application and some Kafka topic, it could sit there proxy, do some limited mediation. But for all the other use cases, it essentially fails. And what happens is that teams are left with this decision, okay, so if I want to implement streaming EDA, if I want to actually become this industry 4.0 kind of company running MQTT, and I want to be able to expose that information to specific internal, or I think in the promised land, a lot of external consumers, I'm going to be kept behind, right? If my gateway can't support these native protocols and can't support that paradigm of communication while keeping it secure and reliable, because that really is the big thing, right? There's nothing necessary about a gateway if you just want to expose something to someone, right? Now there are benefits of having a single point of exposure like gateway, but hypothetically, you could expose anything to anybody if you're not worried about security and reliability. Right. So with the gateway that can't support things like security focused policies, reliability focused policies, think something like rate limiting, controlling the rate at which an API can be called or requested, or setting quotas on the amount of messages that can be streamed, or authenticating specific consumers who want access to those streamed messages, you're really sort of left in this position where you're either held behind or you're having to then build your own sort of patchwork solution alongside your existing traditional gateways, which, as you can see here, result in a ton of challenges, whether that be latency. If you're going to stack multiple gateways on top of each other, for example, that's an issue. You'll have data silos because you have one stakeholder managing some data, some flow of data here, and then another over there. And if you want to actually know what's happening between these specific consumers and producers, you have to look at both. So that data and information on that data is siloed. Your replication, your security surface gets extended. Every single time you add some layer of middleware, that does increase your security surface. So you're adding all of these tools, increases surface. if you're buying multiple enterprise solutions or if you're building your own, either way, you're adding cost when you're having to add a ton of different solutions. And then there's the engineering toil, right? Having to build and manage multiple systems to essentially accomplish the same task, just for different sets of APIs and protocols. It's annoying, right? It would be a lot cooler and a lot easier if you could just have one. And there is one challenge here that I forgot to mention. I have alluded to it a little bit. You have consumers out there. And I think, we talked about this paradigm earlier. The first paradigm typically is your eventing backend systems, right? So you might introduce something like MQTT or introduce something like Kafka, et cetera, et cetera. But these consumers need access to that data. Are they going to set themselves up as MQTT clients? Are they going to set themselves up as Kafka clients? There are reasons to do that. And sometimes there are reasons not to do that, right? So this critical information needs to be able to get into the hands of those consumers, those subscribers, those applications. It's very, very difficult, right, when you don't have those specific mediation solutions in place. So Ravi, if you'll go to the next slide real quick. This is where Gravity comes in. So you'll see all the challenges I mentioned. Gravity comes in to solve these challenges, right? Essentially what we are is one gateway, call ourselves an event native solution built on an evented gateway that natively supports a variety of protocols, API styles, communication paradigms. We are not limited to the synchronous world of request response, REST API, SOAP web services, although SOAP can, I guess, typically be implemented asynchronously. And we're not just limited to the asynchronous world and the streaming world. We support both. It's one gateway that you can implement that can proxy request response, it can proxy messages, it can apply policies to the request response level or the API call level and the message level. So it can sit, for example, between something like a HiveMQ MQTT broker and sit there and protect access to that broker while exposing that information to external consumers securely, reliably, etc. It can do the same thing for Kafka. If you have Kafka back there, you can also expose that Kafka topic as a REST API or a webhook or a WebSocket API, right? And if you wanted to get information from, let's say, that WebSocket client, because WebSocket goes bidirectional, for example, or REST, if you wanted to post into that MQTT broker, Gravity supports that too. And I mentioned earlier this one challenge of how do you even find access to these services, right? It's really cool to essentially be able, in the consumer's eyes, to create a webhook over MQTT or webhook over HiveMQ API that they can access, but they need to know how to access it, right? So one of the other cool things that Gravity does is we provide a developer portal where you can actually list and expose that specific service or API in a self-service catalog for internal, external consumers to access. So when one team says, okay, I've created a service that allows me to expose my HiveMQ and MQTT broker over REST API, no other team in the organization, for a specific set of data, of course, no other team then has to recreate that, right? If their application needs that service, that original team can list that service or API in that developer portal or catalog, and then whatever internal consumer, of course, that API publisher gives access to, will be able to access that in a self-service manner, subscribe their applications to it, et cetera, et cetera. And of course, that same applies to external consumers. The developer portal does include specific authentication methods so that you can make sure only the right consumers actually access these APIs. So no worries there. But I think one of the really cool things here about the sort of external use case is not only can you expose that API or service in a self-service manner, you can also use Gravity to layer monetization capabilities on top, right? So for example, let's say you're someone who is capturing specific sets of data in real time that, I don't know, some consumer or some stakeholder is willing to pay for, right? Well, you can use Gravity and HiveMQ for and say, okay, here's my HiveMQ MQTT broker. This is brokering that valuable data. I'm going to put Gravity on top of that or in front of it, however you choose to say that. So you put Gravity on top. You're going to expose that HiveMQ broker over whatever protocol or API style that paying customer wants to consume that data over, right? And say, okay, every single time a message is streamed, you're going to pay me 1 cent or whatever, right? That's the agreement when they subscribe. Or maybe they're REST-based and they want to just ask for that data, and ask for the most recent data every 10 seconds or something. Every single time you call that REST API, which is essentially asking for information from that HiveMQ MQTT broker, you're going to generate a cent in revenue, right? So you can see the benefits here, right? You can actually turn that real-time data that has been so critical to internal systems into products that paying customers will access if that data is something that's valuable. And I think oftentimes, Ravi, I'm sure you'd agree, the data that's been captured in Industry 4.0 use cases is oftentimes very valuable. If you're a manufacturing company, for example, let's say you're capturing information on carbon footprint, I'm sure regulators are interested in accessing that information, right? Or specific.
Absolutely.
Interested in that.
Yeah, totally. Yeah.
So you could expose that to them however they want to consume it, and you could put a payment plan on top. So it works for everybody.
Yeah.
So Ravi, if you'll skip to the next slide. This is essentially what, I've sort of already covered this a little bit, but if we had to summarize the benefits of what Gravity and HiveMQ bring, essentially it's bringing the benefits of MQTT to more consumers, right? If in the first two paradigms are sort of limited to internal stakeholders for specific security and reliability reasons, Gravity and HiveMQ together allow you to bring the benefits of MQTT, the data captured by your smart devices, your sensors, whatever, to whatever consumer that you want it to have access to, right? So essentially what ends up happening on the Gravity side is that we have this MQTT backend connector that supports MQTT brokers in MQTT 5, such as HiveMQ, right? We can mediate between MQTT or HiveMQ and REST, WebSocket, Webhooks, SSE, and more to come, which is very exciting. And this essentially what this allows you to do is expose MQTT resources as gateway, REST, WebSocket, Webhook, or SSE APIs in that developer portal, as I mentioned before, all making sure that it's secure. That really is the linchpin in this, right? Because once again, you could totally expose this if you want to whoever, but it's not necessarily going to be secure unless you enforce some sort of logic or some sort of set of criterion, which you can do with something like an API gateway, like Gravity, once again, at the API call and at the message level, which, as we mentioned, allows you to productize and monetize your MQTT data and your HiveMQ data streams securely and reliably. Ravi, if you'll skip to the next slide. This is actually a real sort of world use case that one of our customers has. So I wanted to run through it. Then I'm actually going to show this use case in a demo on once we get past this slide. So essentially what they have is they had all this MQTT infrastructure, HiveMQ infrastructure, all internal backend systems, and they had specific customers that wanted to be able to access that data. They're willing to pay for that data, and they want it in real time, but they prefer to consume that information in real time over Webhook, right? MQTT clients, they could have done that, but Webhook already existed, and they didn't want to have to rip and replace necessarily, right? So Webhook was their chosen form of communication. So what they're using is they're using the Gravity gateway as that layer in front of HiveMQ. They're exposing those MQTT resources, allowing those consumers to subscribe essentially to that MQTT broker, even though subscription is technically with the gateway. You're practically subscribing to messages that are being published by that MQTT resource over a Webhook callback URL, right? So what they do, this service /API has been created. The customer's internal users can find that service or API in the developer portal, right? They subscribe their application to it. And then as these sensors, which are set up as MQTT clients, are publishing information to the MQTT broker or streaming it in real time, that information is then being sent from the broker, since the broker is intelligent and knows where to send that information, to the gateway. The gateway intercepts that message, applies whatever policies, whether it be quota, whether it be some sort of authentication policy, whether it be some sort of filtering policy. There's a ton of them available. And then based on once those policies are enforced and we're said, okay, consumer's good to go, information is then streamed over that Webhook callback URL to that client, to that client application, which is owned by the customer, and money is being made per transaction there, right? So it's a pretty cool use case. It's one of our initial HiveMQ and Webhook use cases. So we're really excited to be able to service that. And Ravi, if you'll then give me control of the screen, I'm actually going to run through this use case in a demo really quickly.
Let's do it.
Let me get this up. All right. So as I'm pulling this up, you'll notice that I'm here in Postman. So one of the cool things about Gravity, we have a fully functional UI that makes things really simple to use. But everything that happens in the UI, of course, is there's an API under the hood, right? That's steering the car. So what I'm going to show is how you actually do this using what we call the management API. We have a lot of our customers that are using the management API. specifically because we have a lot of technical teams that are interested in things like infrastructure as code, for example, or automating a lot of this. So the management API makes this possible, but of course, as I mentioned, there is also a UI in front of this, and we can make sure that resources are shared that show what that looks like. So essentially, I'm just going to walk through what I'm doing here using the API, right? So first, I have to create this API, right? This API is then sent to the gateway, which right now is already running. So what I would do is I've already done it just for the sake of making this demo easy, but you'd send this API and then you would define this and set this as your API. Then you have to create your plan and then post this information to the gateway so the gateway knows what plan this is running on. For the sake of this demo, we're using an open plan, right? So there's no API key, there's no security necessities here, just much easier for the sake of a demo, but you could have something like an API key plan here, for example. So this plan is then set. I would send it just like I did the API. Then you have to start the API. You're going to create your application, right? You can see here, this is the application that we're creating. Will be subscribed here. And then now here, this is where things get interesting. Before you can subscribe to API, right? The thing that you really need to do with what you have to do with the webhook is you have to define your callback URL, right? This is essentially the URL or the vehicle of communication after that event happens and stream from that client to the broker to the gateway. The gateway is then going to know where and how to send that information. That is all dictated by the callback URL, right? So what I did is I go here, I have my URL here on my webhook site. I copy this, and then I set this as an environment variable right here. And then we are good to go ahead and subscribe to this API. And before we add a policy, I just want to show you all what it looks like, which is pretty cool. So you'll see here we have HiveMQ open here on the left. We have our webhook site up here. It's a message sent in real time. See here, click it twice, 2 messages sent in real time. We'll do it again. This is a message sent in real time that my customer is willing to pay for. Oops. Again, there's some magic here, right? This is HiveMQ communicating over MQTT. This is Webhook, which is pretty cool. So we publish this, and then MQTT subscription has that message sent over in real time over that specific callback URL. But as I mentioned, that's only part of the magic, right? Protocol mediation is one thing. It is really cool. It does essentially expand your market share and expand the potential of consumption of your data and resources. But I want to show what actually applying a policy looks like. So in Gravity, using the API, you'll be adding a flow. Flows are essentially policies, which are essentially logic, right, that the gateway will execute in order to protect that API, make sure the API is only consumed by the right people, right time, in the right manner, et cetera, et cetera. So what we're going to be applying today is what's called a message filtering policy. Essentially what a message filter is, it's a set of criterion that you define, which will then define a filter, right? So I would say, for example, for this one, the filter is going to be based on whether or not in the metadata, there is a property of feature and a property value of demo filter. So these have to be here in order for the gateway to allow the message to that filter. The gateway is going to intercept it. If not, it's not going to let the message come through. If so, right, it will let the message come through. Right, so let me show you what this looks like. So what I'm going to do is I'm going to add this flow to the API. Now, one thing to know, whenever you apply a policy, you need to redeploy that API to make sure that it's up to date. So the flow has been added. Let's go back to MQTT. Remember, this is what we just sent over. Oh, 1 second. Let me fix this. Must not have been deployed properly. So let me send this over. Great. API has been deployed. Still coming through. Okay, let me reconnect here. Should be working. Fortunately, classic live demo.
Yeah.
Yeah.
Don't we all love live demos?
I do not love live demos when this happens. Okay, this should be sent. Let me check Docker and see what's going on my end.
Do you think in the meantime we could maybe take some questions, or
Yeah, sure.
Jayashree?
Let me get this thing reconfigured on my end, and then we'll take questions. And I'll read some of this.
Yeah. I think we got through most of the demo. I believe. If we can finish that off. Jayashree, do you want to like run the poll questions before we take questions?
Yeah, sure. Let me launch the polls, and you can start moderating the Q&A.
All right. Okay.
And I will also include a link to our contact us form. If you guys have any follow-up questions, feel free to reach out to us. So carry on.
Yeah, thank you. Thank you so much again. And thank you, folks, for attending this webinar and all the wonderful questions. I do see 3 questions here, and I believe there's 1 question in the chat that we can also address. Jamie Hart, I know you asked, I would like to understand how customers are leveraging AI to support IoT devices. Is this something that HiveMQ needs to develop, right? Great question. So HiveMQ is a message broker, or a data broker, as we call it, right? So an MQTT-based data broker. And what that means is that we are in the business of ensuring that you have the data available, and it's bidirectional, and it's available for all your advanced use cases. We really don't do the AI itself, because obviously we want to leave that to the folks that specialize in those things, like the Azures and AWSs and Kafka providers and others that actually do the AI. And we actually ensure that we provide the data, and we have this like what we call the infinite loop that ensures that the data is always available, and it's something that you can trust and build on top of. Now, we are actually kind of like working on some contextualization of the data, which means that obviously like you want to be able to trust that data, right? So that part is key to ensuring that you can still make sure that that data is in the right format. For example, it has the right lineage and things like that. Those are areas that we're getting into, but we don't do the AI part. But great question. Thank you. The second question I have is Ranjan Yambem. I hope, Jamie, I answered the question. If you have any further questions, please do follow up, and happy to answer that. Ranjan basically is asking, sir, I'm using cloud-based cloud-based broker, and it has about 10 gig storage. So my question is, how can I download the data captured in this broker? Now, HiveMQ itself is not a storage mechanism, right? It is basically the data. It enables data movement. And so you still are responsible for ensuring that you connect up, for example, like some kind of a storage device, maybe like a database that can capture this device and store it, or a data lake, for example, that can capture this device, combine that with, say, other pieces of device. And that's kind of like what HiveMQ can enable. And so, so you would have to build out some storage mechanism on top to be able to capture the data and use it for whatever purposes you need. But obviously, like once we connect the broker to that storage device mechanism, we'll ensure that the data is available and most up to date. That part will ensure that we take care of. So that's Ranjan. That's the answer to your question. Feel free to ask any further questions, clarifications based on this as well. Sandeep has a question which is very interesting. The REST API for pull and get data for a particular topic, or for post the data on some topic, or is any other purpose of REST API? Okay. Let me repeat the question. The REST APIs for pull, get the data for a particular topic, or just for post the data on some topic, or is there any other purpose for REST API? So do you want to take that question? Are you able to do that?
Yeah, I can. I'm almost back up and set up. Let me get here. So the REST API is to pull or get the data from a particular topic, or just for posting on some topic. Oh, okay. Yeah, so it can do both. So for Gravity and HiveMQ specifically, we support posting data from a REST-based application to an MQTT broker. Also getting, so let's take that. Getting's kind of interesting, right? Because you think about MQTT, and one of the major benefits of MQTT is that sort of asynchronous streaming-based communication, right? But sometimes you might need that broker to get information in real time asynchronously from the client, but so from that MQTT client. But for the actual consumer application up here that needs access to, let's say, temperature data, maybe for some reason they just need temperature data to be updated in real time every 30 seconds, right? So you can
Yeah.
configure that REST API to then pull for maybe, I don't know, the most recent temperature every 30 seconds, or the average temperature over the past 30 seconds. Then that would be the information that would be exposed in that consumer application. For posting, same thing. You could post whenever that application needs to that MQTT broker.
Great. Great. That's a great answer. Thank you so much. Sorry to disturb you. I know you're trying to set up your demo and bring it back on.
I think we're almost there.
Okay. All right. So Ranjan had a follow-up question. Sir, in case of security, how much HiveMQ MQTT is safe, right? Obviously, security is paramount, right? Especially when it comes to IoT, security is key. We have actually built out a few things to ensure that the data in basically that flows through the MQTT broker is safe, right? The X5.9 certificates, the user ID password authentication, all the regular security protocols that are needed to ensure that the data is absolutely safe. Both MQTT as a protocol offers it, and HiveMQ has like additional security mechanisms to ensure that the data is secure when it's at rest and when it's in movement. The other thing that we have done on top of that is we know that IT teams for, like, say, manufacturing companies or others, they have like a very extensive security policy, and obviously they want to be able to implement the same thing on the broker. So we have something called a security extension that we offer to our customers, where it essentially becomes the broker becomes a pass-through. So you can actually apply your security policies that you have, say, to other IT components that you might have into the broker. Like, for example, if you have Active Directory, if you have LDAP-based security policies that you offer on your other IT components, you can do the same thing on the broker as well. So that's another thing that our customers are highly appreciative of, because now you can consider that broker as any other component on your IT infrastructure, and it has the same amount of security. Okay, great question. And hope, Jay, I answered that question. All right. So Steph has a question that is a follow-up to this. Is security extension part of the dedicated plan, or is it a separate product entirely? So the way we sell extensions is basically it's and we can talk about like the pricing, right? Typically, extension is not like standard as a part of our core offering. Like, we have what we call professional and enterprise licenses that we offer, and typically extensions are an add-on, and we typically charge it as a percentage of the broker pricing itself. And absolutely, Steph, if you want further information, we can follow up with you. We can have our salespeople talk to you to understand your specific use case, and we can even provide you a quote. But that's how we do it. Okay, so Jamie, you had a question about do MQTT messages go through SMSC, or do they typically proceed which does not go through an SMSC? Unfortunately, I don't know what the SMSC acronym is, and it doesn't ring a bell immediately for me. So if you don't mind, if you could just follow up and ask the question again, or give more clarity around what that is, would love to address that question. Thank you. And you did have another question about what percentage of IoT devices leverage MQTT protocol versus other protocols. We actually did a survey with some 500 or so participants that where we specifically asked questions around, if based on your IIoT protocol, like IIoT strategy, right? Which are the most common mechanisms that you employ from a connectivity perspective? About 68% of the respondents answered MQTT, right? And we can point you to many other such surveys that kind of rank MQTT as really high when it comes to data connectivity. And the reasons are obvious, right? I mean, it's a publish subscribe based protocol. It's based on TCP/IP. It's very, very kind of adept at adapting to low connectivity, low bandwidth situations, harsh environments, and it has the ability to connect to other systems easily, right? So it's becoming a very ubiquitous protocol when it comes to IoT for edge to cloud or edge to enterprise use cases. So I noticed you referenced SCADA, and then this is a question from David. I noticed that you referenced SCADA, but I assume BAS systems are also supported. Okay, if you're a third-party analytics partner, how do you avoid a different API for each publisher? They all Okay, they all names endpoints differently, or a few might use haystack. Okay. So yes, so the way we, yes, so we do support a SCADA system. For example, inductive automation is a very common SCADA system that you find out there. And inductive has the ability to talk MQTT directly. It has a native MQTT client, so we can talk to those systems. If the BAS system that you're referring to already has an MQTT native client, we can obviously talk to it directly, right? If it does not, we can actually create an extension from our system using our SDKs, and that allows you to talk to that BAS system. And as far as like different partners having different APIs, so we are kind of like have standardized our SDKs, and then using that SDKs, you can kind of like talk to any of the other systems. For example, we have an extension talking to Kafka, right? Where we are not using their APIs, we are using our APIs or SDKs to talk to their system, if you will, right? Or in the Gravity use case, for example, if you want to talk to Webhook, we'll talk to the Gravity's API management system, and through that we can talk to like a Webhook or another system that that Gravity can talk to that. Do you want to add to that?
Yeah, can you repeat the question really quickly? I just got the demo thing working, so I.
Oh, okay. You know what? Go ahead. Okay. How long will it take? How long will the demo take?
I got 30 seconds to show it. Yeah.
30, okay. Please go ahead. Why don't you finish that, and then we'll
yeah,
since
sure.
you're
sure.
Yeah.
Yeah. So the issue, I just need to respin up my Docker instance here. So apologies for that, everybody. So let me go back to Postman and show you all what we have here. So as I mentioned, we added this flow, right? If you remember, this is essentially, we're adding a policy, right, to this API. So it's a message filtering policy. That filter is just based on a certain set of criterion, right, which will either let information in or not, right? So the message will be intercepted, now they're allowed to go through to the consumer or not. This filter is based on this, right? In the metadata, you need to have a property as feature and a property value as demo filter. You'll see that represented here. So I have already applied this policy by sending that request. I redeployed my API. And if we go here, right? So what I'm going to do, we have what needs to be in there right now. That property is feature and property is demo filter. If I am to make this property features, it's no longer feature property isn't there, it's just features. And I click this through, nothing, right? It's not going to come through, right? I'll take this off, just do feature. And you'll see there information sent in real time, right? Now, admittedly, this is a very simple high-level use case. In production use cases, the filters are going to be much more complicated, but you can think about a real-world use case where you want maybe consumer A to only get messages when certain metadata there, consumer B, certain metadata, consumer C, maybe if it's temperature, consumer C only wants temperature when temperature changes by 2 degrees. Consumer B just wants temperature when it changes every time it changes, et cetera, right? So these are all filters that can be applied by Gravity. So once again, this policy is enforced at the gateway.
Awesome. And this is great because we already have some of the security postures that we offer as a part of MQTT itself to ensure that publishers and subscribers, only the authorized publishers and subscribers can share information. I think this is kind of like an extension of that. So like if a webhook also wants to access this information, they can use your API management to ensure that like they have those security policies that ensures that only the right folks or right applications get access to the right data. That's fantastic.
Yeah, absolutely. And I mean, and the other benefit, of course, is if I'm some external customer or even an internal customer, I can find this service. You can think of this service as accessing MQTT over Webhook in something like a centralized developer portal, right? And of course, you can use Gravity to then manage consumption, view consumption, audit consumption, et cetera. So there's tons of benefits of using HiveMQ and Gravity together.
Absolutely. Yeah. And just to be clear, obviously, there are use cases specifically to HiveMQ. If you want to connect to Kafka, you have extensions. But what we're talking about here is that how can the power of Gravity and HiveMQ come together, if you will, to ensure that we can offer additional use cases. For example, Webhook or HTTP GET or HTTP PUT, your synchronous and asynchronous communication applications that need this information that historically didn't have access to MQTT now can get access to MQTT through Gravity and HiveMQ working together, right? So right now, there was a question from Jamie about like, hey, do you sell your Gravity as a service, or do you also offer also sell your Gravity as a platform component? Right. I mean, maybe that could be a follow-up because we don't have much time. We could follow up with you, Jamie, on like how we do that. right now, we obviously like each of us are coming together. We combining the power of the two companies. We can talk about like if you have a common use case where you need a broker as well as the API management system, we can certainly address that. We have 1 minute. I know, Jamie, you came back with the answer that it's what you're referring to SMSC, Short Messaging Service Center. You don't need to. MQTT is kind of like a completely different mechanism. If you will, it doesn't go through SMS. You don't need. So it's basically strictly based on the like the broker and the communication between the client to the broker that then brokers the communication out to other clients or go through an API management system to go to like a webhook or other applications. So, okay, one question from Steph. I know we are up against time. I'll just take a minute if it's okay, Jayashree, maybe just answer one more question if that's okay.
Yeah, sure.
Yeah. How does this API management hook into Sparkplug? Is that a format Gravity supports, or how should I see Sparkplug in this whole story? So Sparkplug is specifically a IIoT or MQTT data framework, if you will, right? Right now, obviously, like Gravity doesn't understand what Sparkplug is, but then like HiveMQ understands. And if there is a use case where there is a specific piece of data needed by like a webhook pull, if you will, we can provide that data and the context through the Gravity's API management system, for sure. In the future, we'll have more integrations where the data is interpretable at like different levels, if you will. But right now, it's kind of like managed through HiveMQ. All right, so I think we answered most of the questions. So if the questions haven't been answered, we are happy to get back to you. So go ahead, Jayashree, if you have any final thoughts. I'll just pull up that final slide, if that's okay with you, where we have some good information. Okay, go ahead.
Thanks, Ravi. So we do have like a white paper around manufacturing, and there is also a combined white paper written by Gravity, where it actually shows API management for IoT with Gravity and HiveMQ. So Alex, maybe you can talk about it, like a quick overview of this white paper. This will be available in the follow-up email too. You can download it from there as well.
For sure. Yeah, I think the white paper, or sorry, go ahead.
Go ahead, Alex.
Yeah, I think the white paper is great. I think it covers a lot of what we've discussed today. Of course, a bit more in depth, white papers usually are. So we go into sort of the needs for MQTT, the benefits of MQTT, and the benefits of sort of stacking API management on top of your IoT event brokerage using a HiveMQ or an MQTT broker. I think it's something that a lot of people don't think about, right? You have teams that are running IoT systems, setting up MQTT and HiveMQ brokers, and this thought of being able to actually expose this information to various sets of internal and external consumers and manage that via something like a partnership between HiveMQ and a Gravity API management solution. Sure. It's a new approach, but it is an approach that can drive serious efficiency, security, benefits for sure, reducing vulnerabilities, and of course, it can drive revenue, right? As we've mentioned multiple times on this webinar. So that white paper really goes into it in a lot of depth. So definitely go and check that out. I think it is a really valuable resource.
Yeah, and then we have a live stream coming up between the two companies as well in April. Yes. That we can make sure that we share that information about that with the folks here as well.
Absolutely.
So look forward to it. That's it. Jayashree.
Awesome. Thanks so much for a fantastic presentation. Thanks, Ravi. Thanks, Alex. And I'm sure our attendees had like really interesting key takeaways from this session. Like I already shared, we will be sharing the recording as well as the presentation over a follow-up email. So if you have any questions, feel free to contact us. I have already shared the link to our contact us form. And if you have like really technical questions, you can also reach out at community forum, and the contact details of Ravi and Alex are there in the slides. You can reach out to them. There are like a couple of questions we were not able to cover. We will get back to you. Also, you can reach out to us if you need that information really early. So thanks everyone for tuning in. See you all next time. Take care. Bye-bye.
Thanks everybody.
Bye-bye. See you.